Hi, my name is Shahram Kandaharizadeh, and this presentation describes modeling illumination data with flying light specs. This is joint work with Hamed Ali Mohammadzadeh and Daryan Mehraban. This research is supported in part by a grant from the National Science Foundation. A flying light speck is a miniature-sized drone configured with light sources that produce different colors and textures. I refer to them as FLSs. An FLS display occupies a fixed 3D volume to render illuminations that may use a large number of FLSs. These illuminations provide true depth without requiring the users to wear virtual reality headsets or AR glasses. They are realized using swarms of FLSs. An FLS display may render a point cloud or a point cloud sequence. A point cloud is a set of 3D points representing virtual and real worlds in multiple dimensions. A point includes spatial coordinates and attributes such as color. We are looking at a rose point cloud sequence consisting of 115 point clouds. Each point cloud consists of approximately 65,000 points. An FLS display may use an FLS to render each point, requiring 65,000 FLSs. In a paper that appeared in the ACM Multimedia last year, we presented MOTIL, an algorithm that computes flight path of FLSs to render a point cloud sequence. An objective of MOTIL is to minimize distance traveled by FLSs. It's a divide and conquer algorithm that constructs a 3D grid on each point cloud to compute travel paths. It's highly parallelizable. However, it's time-consuming and computationally expensive. For sequences that are displayed repeatedly, it makes sense to store MOTIL's computed flight paths in a file and read the file instead of executing MOTIL. This is the primary contribution of the paper in your ACM Multimedia Systems proceedings this year, and the open source software release that accompanies it. Here's the conceptual model of the FLS flight paths. It is accompanied with a bag file implementation. We selected bag file format because it's supported by popular packages such as MATLAB, Python, ROS, and others. The GitHub link for our software is Flying Light Spec. The bag file implementation is in the FLS bag file repository. It includes the bag data file representation of the rose point cloud sequence. I thank NSF for their support of this research, and thank you for listening to this presentation.